let's continue looking at some of the questions from our test review for the second half of Unit 1. Here in question number 4, we're given some functions and asked to determine whether they are even or odd or neither. And there's two ways you can go about this. We can take the graphical approach, or we can take the algebraic approach. So here on question A, y is equal to 3 times the absolute value of x. This is a great question where the graphical approach would work really well, because you could probably sketch that graph pretty quickly. This is just a vertical stretch of the absolute value parent function, and so my graph is going to look something like that, just a quick sketch of the graph. Based on the graph, is this function even or odd? Now remember, even means that the function has y-axis symmetry. Odd means that the function has origin symmetry, or it has that diagonal symmetry that we talked about in class. Now this graph is symmetrical over the y-axis. We do have that y-axis symmetry, and therefore it's even. Now down here on question B, we've got 4 times x to the 1/2 power. This is a little bit strange because we've got that 1/2 power. We need to rewrite that. If you remember from your exponent rules, when you have a fraction power, that can be rewritten as a square root. And so this function here on B is actually 4 times the square root of x. Notice that 1/2 power is only for the x, and so I've only put the x under the square root. Based on this, again, I think we could quickly sketch a graph of this function. We know that the parent function, the square root parent function, starts at 0, 0 and goes into the first quadrant. Multiplying by 4, that's just a vertical stretch of that graph. And so a quick sketch of the graph would look like this. And so now we need to ask ourselves, is this function even or odd, or possibly neither? Do I have y-axis symmetry? Well, no, I don't, because I don't have anything on the left side of the y-axis. Do we have origin symmetry? We do not, because I don't have anything down in the third quadrant. And so in this case, this function is neither. Question C. Again, I think that graphing is the way to go here. We've got a parent function that we know, the x squared function. And the transformations here are that it's going to be shifted up 1. Actually, I should start at the beginning. We've got a vertical stretch of 3, a negative here in the front, which is going to reflect the graph over the x-axis, and then finally a vertical shift of 1. And so our graph here is actually going to look like this, a sketch of the graph. And so then, do we have an even graph, an odd graph, or neither? Well, you can see here that we again have y-axis symmetry. My graph is symmetrical across the y-axis, and so that means this one is even. Finally, question D, 1/3 x to the 5th. Now this is an instance where I think the algebraic approach might be a little bit better for us, because maybe we're not sure what the x to the 5th graph looks like. It's not one of our parent functions that we study. So remember, with our algebraic approach, if a function is even, then what that means is that if I substitute in a negative x, my output is still going to be the same. If I put in positive x or negative x, the output is the same. For an odd function, if I substitute in negative x, I'm going to get out the same value as positive x, but my sign is going to be different. We've got the same values, but different signs. So for this example, I'm going to substitute in what if I put in a negative x to the 5th? Well, if I have a negative and I raise it to the 5th power, it's going to stay negative. And so this is going to be equal to negative 1/3 x to the 5th. So notice I have basically the same thing that I started with, except that this time the result is negative. That matches our algebraic description of an odd function, and so this function is odd. Question number 5, describe the transformations that will map the graph of f of x equals x cubed to, to g of x is equal to 0.4 times negative 2x plus 5 raised to the third power cubed minus 1. Now on this question, I want to just add in some parentheses here to change the question up a little bit, make it more like questions that we did in class. Let's put this x plus 5 in parentheses. And then this whole thing is in parentheses or brackets, if you want to use brackets there, raised to the third power. Based on that change, let's talk about all of our transformations here. If I start on the inside, which is where we should start, let's start with the x right here. First of all, what's happening to x? This plus 5. Well, that means that we have a horizontal shift to the left 5 units. So that takes care of that part. The next transformation that we have here that's happening to the x is this negative 2 that's being multiplied by the x plus 5. That's going to give me a horizontal compression. Remember that whenever we're dealing with things happening to the x, it's going to be the opposite effect of what happens when we do that to the y. If I multiply a function by negative 2, well, I'm sorry, I'm just talking about the 2 right now. If I multiply a function by 2, that's going to stretch it. So if I'm multiplying the x by 2, I'm going to get a compression. Now let's talk about the negative. That negative there on the x is going to reflect this graph over the y-axis. Notice all of these changes here that I've been describing have been changes that are being made to x, because all of these transformations here are grouped in here with the x. Now the other transformations that I have are this 0.4 outside and the minus 1. Let's deal with the 0.4 first. It's being multiplied times that cubic function, and so that's going to be a vertical change. And since it's 0.4 less than 1, that's going to be a vertical compression. Finally, the minus 1, we've got a vertical shift down 1. So we had a lot of transformations there in that one function, and we've got descriptions here of each of them. Let's look at one more question in this video. What is the inverse of f of x equal to 2 times the square root of negative x squared minus 4 plus 3? Well, whenever we're finding an inverse, remember that we want to switch the x's and y's and solve for x. So the f of x here, that's like my y. So if I switch x and y, I'm going to get x is equal to 2 times negative y squared minus 4 plus 3. So I need to solve this for y. The first thing that I'm going to do is subtract this 3 from both sides. And so I have x minus 3 equals 2 times negative y squared minus 4. The next thing to do would be to cancel out this 2 here in the front. So I'm going to do that by dividing. Those are going to cancel. X minus 3 over 2 is equal to negative y squared minus 4. Next step, we should add 4 to both sides. Now be careful here. I'm adding that 4 to everything that we have already, equal to negative y squared. Now at this point you may be thinking, well, it's time to square root both sides, but I still have that negative in the front and I really need to get rid of that before we square root. So I'm going to divide both sides by -1. And if we do that, I end up with negative x minus 3 over 2 minus 4 is equal to y squared. And so now, last step, we can square root both sides. I'm going to move up here. And if I square root both sides, y is equal to the square root of negative x minus 3 over 2 minus 4. And that would be our inverse function.